Hello students, welcome to IMS GATE Academy, and now we are discussing the foundation course for engineering mechanics, particularly for the GATE aspirants for 24 and 25, right? Now we have discussed dynamics part. In the dynamics part, we have discussed kinematics of particles, right? Now here we are at the third part. As you know that myself, I am Dr. Vijaya Kumar. I am going to teach you the foundation course of engineering mechanics for particularly 24-25 GATE aspirants, and very basics I am going to teach you. Alright guys, right? Now these basics are very essential for for preparing the 24-25 candidates of GATE. Alright, now let's move for today's topic is kinetics of particles. So last class we had been discussed about kinematics of particles. In the kinematics of particles, we have considered without force and particle shape and size, the body shape and size not considered, and particle only we have considered, and we have solved some problems such as u equal to u plus a, v equal to u plus at, s equal to ut plus half at square, v square minus u square is equal to 2as. So these kind of things we have discussed, and also we have already solved some problems without considering the forces on the particle, right? Now today's our topic is kinematics of particle, right? So in this kinematics of particle, as you know that, so the particle, we are considering the force also in the body. Suppose if we consider any body, on that body if we consider the force which is caused for the motion, and then if we solve the problems, then that is come under kinematics of particles, right? However, you know that particle I have defined, the size and shape of the body will not affect the motion of the body, then it is considered as a particle. Alright, now kinetics of particles, considering the forces which is caused for the motion of the particle, we are considering, and we are going to solve the problems, right? So especially for kinematics of particles, if you are going to solve the problems, basically we use three principles. That means three methods we particularly used. Okay, so that are, first I'll describe that. For solving kinematics, not kinematics, kinetics. For solving problems in kinetics, there are three popular methods are used. There are three popular methods are used. Okay, so what that methods are, okay, what kind of problems we have in kinetics, we are going to see today, right? So now the first method is D'Alembert's principle. Okay, D'Alembert's principle. D'Alembert's principle, right? So first method is the D'Alembert's principle, right? Second method is the work and energy method. Work and energy method. Work and energy method. Work and energy method, and also impulse and momentum method. Impulse momentum equation or method. Impulse momentum method. Impulse momentum method. So these are the popular methods we use in order to solve the problems in the kinetics of particles. Now we will see one by one principle. All these methods, three we will describe, and we will solve some examples. But all these three methods are not going to be used for solving one problem. For different kind of problems, we will use different method. Okay, by these three methods only we will solve the problem, but any one method only we can use, right? Don't think that so for one problem we can use all methods, right? So based on the given data, we are going to solve the problems by using these three methods. All right guys, right? Hope you understand. Now let us move for the first principle, D'Alembert's principle. First method, D'Alembert's principle. first method, D'Alembert's principle, right? Now, in that we will look into that. So, what is all about? Okay. Right. Suppose now D'Alembert's principle works on based on the Newton's second law. So, what Newton's second law states that, so when a force F is applied certain mass m such that it is created some acceleration, such that according to the D'Alembert's principle, a sigma fx equal to max in the direction of motion, right? Now, suppose say that a body, if we consider on that body, so many forces are acting in different directions in a different magnitudes. The net force acting on the body, which is create some motion, right? So, that motion here, do remember guys, in particles, in studying the particles, either it is a kinematics or kinetics, we always used to study translation motion only. In the translation motion, rectilinear motion as well as the curvilinear motion we will study, right? So, where general motion and rotation motion will come for the dynamics of rigid bodies, right? That we will start tomorrow, but today's we are discussing with the kinetics of particles, which is completely a translation motion, right? What I am trying to explain you here, D'Alembert's principle works based on the Newton's law of second law. It states that whenever a force is applying on the body of mass m such that it creates some acceleration in the direction of application of force, that is what happening, right? So, now it works on, it based on, not works, it's based on Newton's law, Newton's second law, Newton's second law, right? Right. If a force F applied on a mass, body of mass, such that it create some acceleration on the body, all right, that is what all about, right? Now, here I am taking a body, here I am taking a body, all right guys. Now, on this body, forces are going to be acted, right? So, in this direction, in this direction, in this direction, right? In this direction, in this direction, and then in this direction. Say F1, F2, F3, and F4, and F5, okay. So, these forces are acting on a body of mass m such that it creates some acceleration in the direction of motion, okay. Suppose the net force acting on the body moves the body in this direction such that acceleration created on this body in this direction. Are you getting my point? So, acceleration acts in the motion of in the direction of motion of a body. Suppose all these forces, if you take the net force of F1, F2, F3, F4, F5, F6. So, if net force acting in this direction, right, suppose say that I will write net force, that is sigma F, say sigma F. So, this sigma x acting in this direction such that this body is going to be moved in this direction, all right guys, hope you understand, right? So, now here direction of motion it is, right? Now, let me write that it is a direction of motion. Direction of motion, all right guys, right? So, I hope you understand, okay. Fx is a net force, sigma F is a net force, sigma F is a net force, all right. Now, so if I apply net force in this direction such that this mass is going to be moved in this direction with certain acceleration, say a, according to the D'Alembert's principle, according to the D'Alembert's principle, according to D'Alembert's principle, according to D'Alembert's principle, so sigma Fx is equal to, it is going to be a m into ax, okay, where ax is the acceleration in the direction of x. Why? Because here we have considered our net force acting in this direction. That is why whatever the acceleration of this body because of this force is created, that is in the x direction only, all right, right. Now, here m is a mass of body, m is the mass of the body, right. Ax is the acceleration in x direction, acceleration in in the direction of motion, not in x direction, in the direction of motion, in the direction of motion, acceleration in the direction of motion. All right, guys, I hope everybody understand. I hope everybody understand, right? Right. Now here, so if I consider that sigma Fy, so here also we can write it as sigma Fy is equal to, it is ma into ay. So when the motion in vertical direction, when the motion in x vertical direction, right? Now here the motion is in this direction. Because of this net force, the motion is going to be takes place in this direction, right? Suppose if I take that motion takes place downward because of the force, then acceleration is also in downwards, right? So acceleration also in this direction. Hope you understand. Yes, guys, it is a relation between force and motion variable. Here what is a motion variable? Motion variable is a acceleration, right? I will write that point also. It is a relation between, it is a relation between force and motion variable. Force and motion variable. It is a relation between force and motion variable. Clear, everybody, guys? I hope everybody understand. I hope everybody understand, right? Now, if suppose if there is a no force in x direction such that Fy equal to 0. So if Fy equal to 0, then there will be a no motion. The body is in the rest state, isn't it, guys? Right? So now I hope everybody understand, right? So this is what the D'Alembert's principle. This is what D'Alembert's principle, right? Now here what type of motion it is? It is a rectilinear motion, right? It is a rectilinear motion, right? Rectilinear motion. Right. Now let's go for the second method, that is what we have discussed, work and energy method. Okay, work and energy method. Second method is work and energy method. Work and energy method. Work and energy method, right? Now let me discuss this. All right, now let's go for, suppose I am giving certain force to the body such that it create motion and it moves certain direction. That means we are giving some amount of energy to the body such that it is going to be move. Okay, so now here what I am trying to highlight here, guys, what I am trying to highlight here, that means whenever energy is given to the body, then it is going to be change the kinetic energy of the body, isn't it, right? Now suppose say that, so I am taking one shape here, one body. Right. Here I am taking a body, right, and then I applied a force over here, right? I am applying a force F. I am applying a force F such that it create some motion to this body such that this body is going to be, suppose say that it is in a first position, and after some time then it is going to be, so move to or here. So now it is a second position of the body. So certain displacement has been created. Say this displacement we are considering it as a Sx. Okay. So displacement suffix x because of this force it created some displacement onto the body such that what happened now, we are giving some energy to this body such that it is going to be change the kinetic energy of the body. It is going to be change the kinetic energy of the body. So Right. This is all about work energy method is all about conservation of the energy. So work energy method says that it is based on conservation of the energy. All right. Now let me write this method based on this method based on conservation of energy. Right. So because of the F force, it changes the kinetic energy of the force. Okay. So we are giving some energy to this body such that it changes the kinetic energy of this body. All right, guys. Right. Now let's move for one work done converted into kinetic energy here. Right. Now work done converted here kinetic energy. Work done converted into kinetic energy. Work done converted into kinetic energy. Yes, guys. Okay. Hope you understand. Right. Now let's move for here. Sigma Fx is the net force acting in the direction y. Net force acting in the direction of x. In the direction of x. All right. Right. Now here Sx is the displacement in x direction. Displacement in x direction. Displacement in x direction. All right, guys. Now here, how can we write work done? Okay. Now here, work done is equal to change in kinetic energy. Change in kinetic energy, isn't it? That is what the work and energy principle saying that. This method is saying that like that. What is the work done here? What is the work done here? F into sigma. Suppose say that this is say that it is a sigma F. That means all the forces which are acting on the body, I am taking it as a net force. Okay. All right, guys. Right. Now here what happened now, guys? Now here what happened now? Right. So now here work done, how can we write? Sigma Fx into delta x is the work energy. Force into displacement. Right. Now work done is equal to sigma Fx into Sx, right? Now change in kinetic energy, right? Now here its initial velocity is ux and final velocity is vx, right? So now its mass is obviously we consider it as a m. We consider it as a m, okay? Right. Consider it as a m, right? Now here change in kinetic energy. Work done is equal to change in kinetic energy. How can I write my change in kinetic energy? Change in kinetic energy is equal to, it is half into m into, so vx square minus ux square. All right, where vx is the final velocity of the body and ux is the initial velocity of the body. I hope everybody understand. I hope everybody understand. So if you want, I can write it here. Right here only I'll highlight. Ux is initial velocity of body. Initial velocity of body. Right. Now Vx is the final velocity of body. Final velocity of body. All right, guys. Right. I hope everybody understand. I hope everybody understand. Right. 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 If suppose this relation will be used whenever its force is acting constant, right? Whenever force is acting constant, this relation will be used. Okay, right? If force is not constant, if it is a function of displacement, then we have to use another equation, right? Right. If a force is not constant, I'll write it as, if force is not constant, force not constant, and it is a function of displacement, and it is function of displacement, and it is a function of displacement, and it is a function of displacement. Suppose say that f equal to, they gave that x square plus 2x plus x cube plus 4 x to power 4, like that. If they gave that, then function of force is not constant now. So accordingly it is going to be change. Okay, right. So what I'm trying to simply tell you guys, if a force is not constant, then you're not supposed to use this conservation of energy equation, that is work done is not equal to change in kinetic energy. Now whenever force is not constant and it's a function of displacement, in that case, okay, so in order to calculate work done, we have to use following relation. Okay, right. The above equation should not be used. Above relation should not used. Whenever sigma fx is a function of s, that means is a function of displacement, above equation should not be used. All right. Now in that case we are supposed to use, right, sigma fx into ds integration of 0 to s is equal to half into m vx square minus ux square. This relation has to be used. We have to integrate whenever force is a function of displacement, whenever your sigma fx is a function of displacement. Let me write this capital X, guys. Okay, so whenever it, oh my god, 1 minute, sigma fx is a function of displacement. In that case, so you are not supposed to multiply the force with the displacement, you have to integrate. So in this case, force is not constant, it is a function of displacement. Whenever displacement changes, then obviously force is going to be changed. That is the reason why here, so this relation has to be used whenever force is not constant and it is a function of displacement. In that particular case, we have to use this relation in order to solve our problem. All right, guys, right? Now hope you understand everybody, hope you understand, guys, right? Now let us move for the third method. So here, as you know that it is a displacement and it is a net force and mass of the body and final velocity of the body and initial velocity of the body. Okay, now where displacement varies from 0 to s. Okay, right. So we will solve the problems, not an issue. And generally this happened in the spring force. Okay, generally this happened in a spring force. Generally this happens in spring force. Generally this happens in spring force. Generally this happened in spring force. All right, guys. Right. Now let us go for next method, that is impulse momentum method. It's a very important, you guys. Impulse momentum method. Impulse momentum method. So this method states that impulse force is equal to change in momentum. Impulse force is equal to change in momentum. Okay. So what is impulse and momentum? We know that, right? So force into distance, perpendicular distance, then we are going to get the momentum, right? Here what is impulse moment? Impulse momentum states that, so impulse force is equal to, it is change in momentum. Okay, right. Now I just give you impulse momentum, impulse force is equal to change in momentum. Impulse force is equal to, it is change in momentum. All right, guys. impulse force is equal to change in momentum. Then what is impulse force? What is impulse force? What is impulse force? Right. What is impulse force? Right. When a force is acting on a body for a certain period of time, so if you multiply with the force with the time, then it is considered as a impulse force. Are you getting my point? So suppose say that a force 10 newtons I applied on a body for 10 seconds. Now my impulse force is equal to 10 newtons into 10 seconds. So that I am going to get impulse force. Clear everybody guys? Okay. If a force is applied on a body for certain time, then okay, so impulse force is nothing but force applied on a body for a short period of time, right. Now here I can write it is my impulse force is equal to F into T. All right. So this is what about the impulse force. Now what is change in momentum? 1 minute. Now here change in momentum. Now change in momentum is equal to, it is gonna be a Vx in minus Ux, right. So actually in collision, last class we had been studied collision na. So in that collision what happened? So net force is going to be equal to 0. That means one body is acting on the other body such that the force applied by this body onto this body, net force is going to be 0. That is why momentum is conserved there. But here momentum is not going to be conserved here. Okay. So whenever net force equal to 0, then momentum is conserved, right. That is why we write conservation equation, right. m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. But here you are not supposed to write like that, because here so conservation is not going to be takes place, net force is going to be existed, right, on the body, right. That is the reason why here so change in momentum is nothing but mass into initial velocity minus final velocity is the change in momentum, right. Now here I'll write it is I will write here, right, momentum equation. What is that? Sigma Fx into T is equal to here m into Vx minus Ux, where Ux is the initial velocity and Ux is the initial velocity, Vx is the final velocity, right. If the force is a function of T, right. So this equation we will use. If suppose my force is in a function of T, then what happen, right. So when force is a function of T, when force is the function of T, when the force is a function of time, right, that is I'll write it is sigma Fx is a function of time. If sigma Fx is a function of time, that means sometimes they will give that F equal to for example like that, they will give you like that, right. Now here suppose for example F equal to, they gave like that 3t cube plus 4t square plus 2t plus 4. If like that they gave that, force is not going to be constant. So for every t value, force is going to be changed, right. Whenever your given force is a whenever the given force is a function of time, in that case you are not supposed to use this equation, right. So here also I said the same, right. So here also I said the same, whenever displacement is like that, suppose so Fx equal to, they gave like this, okay. Now 3x cube plus 4x square plus 5x plus 6, if they gave like that, then in that case you are not supposed to use this equation. Fx dot into displacement work done is equal to change in kinetic energy. This relation should not be used. In place of this, you are supposed to integrate this like this whenever it is given, right. Similarly here also, whenever your F is given in the function of time, then you are supposed to write your equation like this, right. Now so your equation supposed to write like this. like this. Now here it is sigma fx into dt. So now here 0 to t, that is equal to change in momentum, that is equal to, it is going to be a Vx minus Ux, you are supposed to write, right? Now like that you are supposed to use, guys. Hope you everybody understand. Hope you everybody understand. Yes, guys. Right now I just summarize the three methods. I just summarize the three methods. What methods we have been discussed so far. Okay, what is the D'Alembert's principle? What it is stating that, so force into this energy conserved. So it is based on second law of energy. Whenever you apply some force on the body such that mass m body, it is going to be create some motion such that fx sigma fx is equal to it is ma. Based on that we will write the D'Alembert's principle, right? Now net force is creating moment in this direction such that my D'Alembert's principle I can write it is sigma fx equal to m into a, right? Now see next work and energy method, what it is stating that it is based on the conservation of energy, right? So now here if I create some force onto the body such that it is going to be create some displacement, right? It is going to be create some displacement, right? Now here displacement, that is work done is equal to this change in kinetic energy, right? So because of this application of force, the initial velocity of the body reaches to the final velocity and it is moved from initial position to final position, right? Now here work done sigma fx into sx is equal to, it is change in kinetic energy, that is mass into v square x minus ux square, like that. So now here I wrote that. But here whenever the force is constant, if the force is not constant, if it as a force is given in terms of displacement, right? Displacement like this right? So x is a displacement here, right? Now x or s cube or s square, s 5s, like this they may give. In that case you are supposed to integrate the fx into your ds equation and change in momentum equations you supposed to write like this, all right? Similarly impulse momentum method. What is impulse momentum method? Impulse momentum force is equal to change in momentum, right? Now what is impulse force? If a force applied on a body for certain period of time, then so force into time is a impulse force. And similarly change in momentum is nothing but it is change in momentum. Momentum is mass into velocity, na, right? Now here because of this force and its velocity changes from initial to final, like that, right? If suppose your force is given in terms of function of t, now like this, okay? Now in this case you are supposed to write your equation and you have supposed to integrate this equation in terms of with respect to the t, right? Then only you are going to get the correct answer, right? So now by using these three methods we are going to solve the problems in the kinetics of particles, right? So these are the very important three methods, and for which problem and which method we are supposed to use, right? We will solve some examples so that you are going to understand, right guys? Hope you understand, right? Now let's move for so question. Have a look on this. Before that, any question? Okay, all right. Now have a look on this question. Have a look on this question. Right. You try to read the question. Right, guys, right now if you want merge with the IMS GATE Academy, right, so the some numbers are schooling are there, you will get counseling, our team will come and motivate you. So how about how all about GATE exam and what kind of content we have, what kind of faculty we have, what IMS is providing the features for the enrolling students, all these things they'll explained through that number. So then those who are attracted to IMS GATE Academy, who like this session and video, so you just click button and try to elaborate and explore our channel. And you just, if you want to enroll, then call to that number so that everybody our team will come and counseling you in order to take the enrollment, right? Now have a look on this question. Right. Now let me read this question. An elevator of mass 2500 kg is moving vertically downwards with a constant acceleration starting from a rest, right? Now it travels 35 meters during an interval of 10 seconds, right? Now find the cable tension in during this time, okay, right? So simple and easy problem, simple and easy problem, right? Now how to solve this problem? An elevator of mass, an elevator of mass. Okay, what is elevator? Lift. Lift having certain weight of 2500 kgs is moving vertically downward. So from certain point, from rest point, it is given from the rest point and moving downwards with a constant acceleration, right? Starting from the rest, moving vertically downward, right? Now it is traveled 35 meter during an interval of 10 seconds. In 10 seconds, it is traveled from the some certain position, top position to the 35 meters towards down, right, in 10 seconds. So find the tension in the table during this time. So we have to find the tension in the cable, right? Now first we are supposed to draw the free body diagram of lift. First we are supposed to draw the free body diagram of lift. Right. Draw the lift free body diagram. Suppose say that this is a lift, okay, right? Now here, so let me, right, now how much its case is? Weight is acting downward and it is 2500 kg, right? So if you want newtons, multiply with a 10. So if you want newtons, multiply with a z, right? You will get the newtons, right? Now obviously we know that, so direction of motion guys, here what is the direction of motion? So direction of motion is in downward. Yes guys, right? They said that a elevator is 2500 kg moving vertically downwards, right? Let me write that. So direction of motion, this is direction of motion, right? So when direction of motion acting downward, obviously my acceleration is also acting downward in y direction. However, we have seen our equation in horizontally, but here it is moving vertically. However, it is a rectilinear motion only. Now rectilinear motion is nothing but it is moving either from backward to forward or from up to down, right? So rectilinear motion in a straight line motion, right? Now here lift is moving from down to lift. Obviously we know that one thing guys, we know that one thing, right, that is tension in the lift is acting upward. Tension in the lift is acting upward, isn't it guys, right? This is the direction of motion. In this direction it is going to be act, right? Now, so now here I would like to highlight one more thing here, that is, you know, what is the force acting downward? 2500 into 10, that is, you know, 25,000 newtons. 25,000 newtons, isn't it guys, right? Now I hope everybody understand, right? Now here what is given? So displacement is given, right? So displacement in xy direction, na, sy you take that, displacement is 35 meters, right? Now your time is equal to, it is 10 seconds, right? So what we need to find? We need to find tension in the wire. Here we are considering the motion, mass as well as the force of the body. What we need to find guys? We need to find tension in the cable. Tension in the cable we need to find. Yes guys, hope you understand, right? Now here first calculate acceleration here. Calculate acceleration. How to calculate acceleration? How to calculate acceleration? Right, here calculate acceleration, right? How can we calculate acceleration? We know that displacement in y direction, time in v direction, And also one more thing we know, guys, one more thing we know. What do we know? Uy. We know that Uy. What is Uy? It is starting from rest. That means initial velocity is 0. Initial velocity is 0. Why? Because it is starting from rest. It is starting from rest. That is the reason why here this fellow is going to be Uy equal to 0, right? Right. Now we know Sy, T we know, and Uy we know. So let's calculate the acceleration. How can we calculate the acceleration, right? Now I have an equation that S equal to ut plus half at square, na? Right? We know the time, we know the initial velocity, we don't know the acceleration, and also we don't know the we know the what is that displacement, right? Now we are calculating in y direction, na? This is y, this is y, this is also in y, right? Substitute that. What is this? Is 35 meters is equal to 0 into 10 plus half into ay into t square, that is 10 square. Now from there I am going to get ay is equal to, all right guys, right? Solve this guys, please let me know, solve this and let me know. I am going to get my A1 0.7 meters per second square. I am going to get. Clear everybody guys? Clear everybody? Now I got AY. AY is 0.7 meters per second square. Now what I need to find? Tension. Tension in the wire I need to find. Clear everybody guys? Clear everybody? Hope you understand. Hope you understand. Right? Now, let me write the equation. How can I write my, according to D'Alembert's principle, I am going to solve the problem. Okay. So according to D'Alembert's principle, all right, according to D'Alembert's principle, right? How can I write my equation? I will write my equation sigma Fy is equal to, it is gonna be a m dot ay. Clear everybody? Yes guys, sigma Fy into sigma, so m dot ay. Now let us apply the sigma net force in the direction of motion, right? Net force in the direction of motion, right? Now let us say that sigma Fy is equal to all right. Now here how can I write, what are the sigma xy in the direction of motion? See here, T is acting upward, 25,000 newtons acting downward. Upward force I'll take positive, downward force I'll take negative, right? Now here I'll write it as T minus 25,000 newtons. All right guys, right? Now here, so let us move for substitute here. What I'm going to get, right? Sigma Fy, oh, directly I'll write. Okay, no problem, I'll write one more step, m dot ay. All right. Now here it is T minus 25,000 is equal to, it is 2,500 into ay, 0.7 meters per second square. All right. This is what I got. Solve this equation, so that you are going to get T. Right. Now let us go and solve this. It is going to be a T is equal to, it is 2,500 into 0.7 plus 25,000, right? Now I am going to get it is 23,250 newtons. 23,250 newtons. Like that we are supposed to solve. So this is what, according to the D'Alembert's principle, I have taken equation in the direction of motion. This I have gave you na in the beginning. This I have gave you, right? Have a look on this guys, right? Have a look on this D'Alembert's principles here. 2 I gave you, right? Now in the direction, in which direction you are going to see, in that direction you can make it. Right. Now this is, oh my god, 1 minute. I will write differently. all right, like this. Okay, so based on that I have solved my problem. Okay, right. Here also we use basic equation. What are our basic equations? What are our basic equation? V equal to u plus at. Now s equal to ut plus half at square, and also v square minus u square equal to 2as. By using this equation, we will find out the acceleration or displacement or time whenever required, and then we will apply our three methods, either D'Alembert's principle or work and energy method or impulse moment system. Okay, impulse momentum method you may use. All right, guys. Now come on guys, come on. We'll go for the next problem. Right. Now have a look on this problem. Similar kind of problem. Similar kind of problem. Try to solve this. Try to solve this. Try to solve this similar problem I gave you for practice purpose. Right? Try to solve, guys. Try to solve. Simple and easy question I gave you. Simple and easy question I gave you. Alright guys, similar kind of problem, same problem, right? But only elevator weight is 1000 newtons, attains an upward velocity of 10 meters per second from the rest in 5 seconds, and uniform acceleration. The tension in the cable is, so take G is equal to 10 meters per second square, right? So guys, if you see here, the only thing is here I have changed the data of weight. I gave you in newtons, and it is moving upward velocity, right? It is moving from the down to up, it is moving from down to up, it is moving, right? Now your direction of motion here upward, and acceleration also in upward. Now your tension is going to be acting in downward, right? Now from there you have to solve the problem. All right guys, all right. So hope you understand, hope you understand. Try to solve, try to solve. All right guys, now here again I am going to take a shape. Here again I am going to take a shape, right? So draw the free body diagram of lift, right, which is moving from, oh my god, is it visible guys, or else we'll go for another shape. Right, in simple small elevator I'll draw. Right. So this is a lift which is moving from down to up, right? It is moving down to up. So now direction of motion is like this. Direction of motion is like this. Obviously acceleration also acting upward direction, right? Now let me write. Now here it is a direction of motion. Direction of motion, and upward velocity is given. Upward velocity is given. That means final velocity is given, guys, right? Now I'll write that. So final velocity, what are the things are given? We will write. So weight is right, weight of lift or elevator, whatever it is, that is equal to 1000 newtons, right? Next is upward velocity, final velocity, and it is starting from rest. See, it is starting from rest, right? So that is the reason why initial velocity is 0, right? So when it is starting from upward to downward, then initial velocity is going to be 0, right? Now final velocity is given 10 meters per second. All right, guys, right? Now let us move for what's the question? Now t is equal to given, it is in 5 seconds, and g is given, that is 10 meters per second square is given. All right, guys, right? Now the tension in the wire we have to calculate. Obviously, guys, so whenever my lift is going to be upward direction, my tension is going to be acting downward direction, isn't it, guys? So sorry, weight is acting downward direction, right? Now weight is going to be acting downward direction, that is 1000 newtons, right? Right. Now here the tension will be like this. The tension will be like this. Clear, everybody, guys? Now how about my AY? How about my AY? AY is going to be acting upward. All right, guys. All right. Now let us write the same equation. What is that? Sigma Fy is equal to, it is gonna be a m dot AY. Sigma Fy is equal to, it is m dot AY. Clear, everybody, guys? Understood? Right. Now here, so we don't know the acceleration, right? So net force we have to find. First we'll find the net force, or we will find the this one, right? First we'll find net force, right? Now net force is equal to, right, net force Fy is equal to, here how can we write? Upward you take T minus 1000 newtons, that's it. T minus 1000 newtons. All right. Now for finding the AY, so for finding the AY, I have used the same equation. I use the same equation, that is S equal to UT plus half AT square, right? So Sx is given. So Sx is given, right? So acceleration and 10 meters per second is given. No, you are not supposed to use this equation here, right? So here we don't know the displacement now. We only know initial velocity, final velocity. We need to find, we know the time also, right? Now we use the first equation. What is that? So V equal to U plus AT, right? V equal to U plus AT we will use. So V equal to U plus AT we will find. Obviously, we will write it is Vy and Uy T U plus it is, oh my god, not it is T, okay, plus it is Ay into T, right? Now Vy is 10 and Uy is 0 plus Ay we don't know, and your time is in 5 seconds. Find out that Ay, acceleration in y direction, acceleration in y direction. You are going to get it is, 10 by 5 only, na? So 10 by 5. So it is gonna be a 2 meters per second square, right? Now we all know mass of the elevator we know now. So mass is given in terms of newtons, right? That is why convert that into kg, right? Now let's write my equation. That is sigma Fy is equal to, it is gonna be a m dot Ay, right? Now here sigma Fx, so that is T minus 1000, right? That is equal to mass 1000 newtons is divided by g, m by g here, guys, m by g dot 2, such that I am going to solve this. This is equal to 1000 is divided by 10 into 2 plus 1000, right? Now from here I can write it is 10 will get cancelled, then it is going to be a 200 plus 1000, such that we are going to get our tension is 1200 newtons, which is acting upward. Okay, like that we are supposed to solve the problem, guys. Okay, right, have a look on this, guys, have a look on this. All right, now have a look on this, drawing free body diagram and moving towards like that. So tricky in solving the question. Yes guys, hope you understand, right? Now let us move for right. Have a look on this question. Have a look on this question. Right. Now what is given? Right. The problem shows three blocks connected by strings over a pulley. As shown in, calculate the tension in string 2. Okay. Right. Now here, can you able to see that string 2? Guys, right. Now here, this is your string 2. Okay. Now this is your string 1. String 1. Right. Right. Now we have to find the tension in string 2. Okay. Right. Now in simple words, I will say that, you know, if I take this is a 40 newtons, if I take this is a 40 newtons, so 40 newtons acting downward and tension 2 acting in the upward direction, right? So now obviously the direction of motion is downward direction. Here a direction of motion is in upward direction, isn't it guys, right? Here direction of motion, right? Here direction of motion is in, oh my god, upward. Direction of motion is in upward. Here direction of motion is in downward, right? Now here my A is acting here, my A is acting here upward direction, right? My A here acting downward direction in the direction of motion, right guys? Now here what we have to do, now, right, now, so now here we need to find the tension in this 2. Okay, this is what our objective, right? For that purpose, first I am finding the tension in the first string and then I'll apply here, right? So that the problem will be easy. For that purpose, what I do now? So I will do, right? I'll consider this as a one body. I'll write one equation in T1, right? I'll consider this total body as a 1. I'll consider this total body as a 1. That means 20 newtons plus 40 newtons, I'll consider it as a one body. And I'll draw the free body diagram so that I am going to get T1 now, right? So I'll apply sigma Fy equal to m Ay, I'll find. So based on that, I'm going to find my Ay, isn't acceleration I'll find. Once I'll get the acceleration, so that it is possible to find out the tension in the string 2 as well. Okay, I hope everybody understand. Guys. I hope everybody understand, right? Right. Now let's go for so consider the first this free body diagram, right? First we'll consider the free body diagram of this first block. Free body diagram of first block. FBD of 10 Newton block. 10 Newton block, isn't it guys? 10 Newton block, right? Now here what happened? Guys? Here, so now see here, 10 Newtons acting downward, 10 Newtons acting downward, and the tension T1 is acting upward. Tension T1 is acting upward. Now here the direction of motion is, upward, right? The direction of motion is upward. How can you decide direction of motion is upward? So most of the students may get the question, right? Have a look on here. Obviously, 60 newtons is acting downward such that these 10 newtons try to lift upward. So that is the reason why I have drawn the direction like this, right? Now here it is your Ay in the direction of motion, right? Now here let write the equation sigma Fy. Sigma Fy is equal to, it is m into Ay, right? From there I can write it is T1 minus 10 newtons is equal to mass is 10 by G is 10 into Ay. So I will write it is T1 is equal to, it is, oh my god, 1 minute. T1 minus 10, T1 minus 10 is equal to, it is Ay. Say it is equation number 1. Say it is equation number 1. We got the equation in terms of Ay, isn't it, guys? Right? Now let us draw the free body diagram of, this 20 plus 40 newtons. 60 newtons we have to draw. 60 newtons we have to draw, right? Now here I will draw free body diagram of 60 newtons. Oh. I will draw free body diagram of 60 newtons. All right, right. Now here FBD of 60 newtons. FBD of 60 newtons block. All right, guys, right. Now here see that 60 newtons obviously acting downward. 60 newtons obviously acting downward. All right. 20 plus 40 here. If you get confusion, because I am considering that 20 plus 40 blocks as a one block. 20 plus 40 block as a one block, right? Right. Now here, guys, now let us move here. Tension T1 is going to be acting in the string 1 is upward. Now here direction of motion. Here direction of motion, guys. Direction of motion here. You know. Oh my god. Downward, right? Now I'll write the same over here. Direction of motion. Direction of motion, right? Now here A is going to be act downward. Okay, A is going to be act, Ay is going to be act downward, isn't it, guys? Right? Now let's plot the equation, guys. Try plot the equation. Right? Now here impulse momentum equation, I will write it is sigma Fy is equal to, it is MAY. Okay, all right. Now here how can I write my sigma Fy equation? It is gonna be a 60 upward direction is T1 minus 60 is equal to C. Their acceleration acting upward, here it is acting downward, right? Now here you need to take it as a minus A. Okay, right? Now M dot A. So now here T1 minus 60 is equal to here, so 60 by 10 into A. So AY, right? AY, right? Now here it is minus. If I want to change the minus, then it is going to be 60 minus T1 is equal to 6 AY. Say it is equation number 2. Say it is equation number 2. Yes, guys. So try have a look on this. Here I just multiply with a minus such that 60 minus T1 it will become, right? Solve 1 and 2, you will get AY. Solve 1 and 2. T1 minus 10 equal to AY. T1 minus, oh my god, T1 minus how much it is? T1 minus 10. T1 minus 10 is equal to it is ay. Say it is equation number 1, right? Here it is going to be a 60 minus t1 is equal to 6 ay. So that it is second equation, right? We just add this equation, plus and minus will go on now, right? Now here 60 minus 10 is equal to it is 7 ay. What do you say, guys? 7 ay, right? Now here it is gonna be a, so ay is equal to, it is gonna be a 50 divided by 7, such that I am going to get my acceleration is equal to, in y direction it is going to be, so we'll keep the 50 by 7 same. So we will solve this at the next one. Okay, now here, so and one more thing, units meters per second square, meters per second square. Clear everybody, guys? Clear everybody? Right? Now here let us move for, let us, oh my god, slides are over. Right? Now here consider the free body diagram of, only 40 Newton, right? Only 40 Newton. What happened? 40 Newton acting downward, 40 Newton acting downward, and your tension T2 acting upward. Direction of motion is downward, right? Now here let us move for, consider 40 block free body diagram. Consider 40 Newton block FBD. Consider 40 Newton block FBD. All right. Now here let me draw that. Now here this is my 40 Newton block. Okay. Now 40 Newton is acting downward. 40 Newton is acting downward. All right. Now my T2 acting upward. Right. Now this is a direction of motion. Oh my god. You may consider direction of motion like that. Direction of motion. Direction of motion, and also my ay is like this. Okay, ay 50 by 7 acting downwards na, right? Now write the equation, sigma fy equal to, sigma fy is equal to m dot ay, right? Now here it is going to be a T2 minus 40 newtons is equal to, it is going to be a 40 Newton by 10 into 50 by 7, right? Now if I solve this equation, then I am going to get, it is a 4 into 50, that is 200 plus 40, right? Oh my god, it is 40, right? Now here T2 you are going to get, calculate this, guys, 200 by 7 plus 40, right? Now T2 is going to be get, please let me know how much T2 you are going to get. How much T2 you are going to get? It is 11.42 newtons. It is 11.42 newtons. Like that, you are supposed to apply, so impulse momentum equation, D-Albert's principle, and also work and energy method as well. I hope everybody understand. Guys. Right? Right. We will solve one more question, which is related to right. Now have a look on this question. This problem model we have solved. No, I haven't drawn that. Have a look on this problem, guys. Have a look on this problem. Two bodies A and B of mass 80 kg, 20 kg are connected by a thread and a move along rough horizontal plane under the action of a force 400 newtons. Alright guys, right? Now here, so two bodies are given, which are masses are given. The masses are given, right? So which are 80 kg and also 20 kg, isn't it guys, right? Now it is connected by a action of horizontal force 400 newtons and rough plane, okay, right? So first body mass is 80 kg shown in the figure, okay. Now the coefficient of friction between the sliding surfaces of bodies and the plane is 0.3 0.3 coefficient of friction. Determine the tension in the thread. Determine the tension in the thread, isn't it guys? Determine the tension in the thread, right? Right here, very simple guys. These kind of problems you can solve in a very simple way, right? Now we apply same sigma fx equal to max. Sigma fx equal to max, so that you are going to get your tension in the block. All right. Right now, see, very simple guys. Here, see. So whenever you encounter these kind of problems, you just cut the thread here. You just cut the thread here, such that the tension on the block A acting in this direction, the tension in the block B acting in this direction, isn't it? Right. So both are equal and opposite direction, right? Now draw the separate free body. And one more thing here, we need to consider friction force as well, because direction of motion is important. So whenever I cut this thread, this body moves in this direction, right? Now because 80 kgs only, right, it is pulling a force this side. Now this body also moving in this direction. Yes guys, tension pulling this body in this direction, right? Now draw the separate free body diagrams of this, and you need to consider, see, if suppose direction of motion in this direction, my friction force is acting here and normal force acting here, right? Normal force at A body, NA, normal force by the floor, NB, and your friction force acting FB like this. This is FA, isn't it guys? Right? Now, so draw the separate free body diagrams of these two and we will solve the problem. Right. So first I'll take the 80 kg block. Right. Now here I am going to take a 20 kg block. 20 kg block. So now here 80 kg is acting downward now. 20 kg is acting downward. 80 kg, sorry. 80 kg acting downward. So into 10 it will become newtons. Now here it is NA. Now it is going to be a FA. So I can write my FA is equal to 0.3 into NA. Isn't it guys? Right? Now here my horizontal force is acting like this, that is how much? 400 newtons, right? Now here my tension is acting like this, right? So FBD of 80 kg block, FBD of 20 kg block. Now my 20 kg acting downward, right? Now here my NB acting like this, right? My friction force FB acting like this, because direction of motion in this direction. So this is also 0.3 NB, right? Now here tension is going to be act over here, right guys? Clear everybody? Right. Now here, so both cases direction of motion, I'll indicate this. Direction of motion. Now here also direction of motion, right? I will write it as both cases. Direction of motion. All right. So for these two cases, you write that sigma fx equal to 0. Sorry, sigma fx equal to ma. Right. Now let me draw that. Sigma fx is equal to ma dot x. Right. Now here fx. So t minus, so forward t plus 0.3 into Na minus 400 is equal to, it is gonna be a Na equal to obviously 80 kgs na, 80 kgs, that we will solve. So because if I apply Fy equal to 0, Na equal to 800, okay, 800 newtons, 80 kg it is 800 newtons, right. Now here it is gonna be a m, mass is 80 kgs and acceleration we don't know, you keep it like this as it is. All right guys, all right, right. Now similarly you write the same equation here, sigma fx is equal to m dot ax. All right. Now here sigma fx, that is this is forward direction 0.3 nb, 0.3 nb minus t is equal to 20 kg into ax. Say equation number 2, say it is equation number 1. Okay, I just elaborate my equation number 1. Why? Because Na equal to it is 800 newtons, right. Here also Nb is equal to, it is 200 newtons, isn't it guys, right. Now substitute Na value and Nb value, so and then you will get so tension in the body, right. Now let us go for elaborate this equation such that what happened, first equation, so t minus 0.3 into 800, that is what na, Na. So Na is 800 minus 400, this is plus I guess, right, this is plus, yeah exactly, this is plus, minus 400 is equal to 80 into ax, right. Now if you solve this, then say it is equation number 1, 0.3 into 800, it's a 240, t plus 240 minus 400 into is equal to 80 into ax, such that I am going to get here, it is going to be a 160. So t minus 160 is equal to 80 ax. Similarly, so next equation, what is the next equation? Second equation. So 0.3 nb, 0.3 nb minus t is equal to, minus t only na, minus t is equal to 20 into ax, right. So now 0.3 into, it is 200 minus t is equal to 20 ax. All right, say it is equation number 2, and I just simplified both equation. So by solving these two equations, then you are going to get, by solving 1 and 2, solve this. So right, by solving 1 and 2, equations, okay, so tension are going to be get 80 newtons, tension is going to be get 80 newtons, isn't it guys? So I hope everybody understand, right. Now here today's session we have finished our kinetics of particles. Tomorrow we are going to discuss about kinematics and kinetics of rigid bodies. Okay, one session kinetics, one session we are going to kinematics we are going to cover, right. So now focus on D'Alembert's principle, work and energy method, and impulsal momentum method. Okay, so hope you understand guys. Thank you all, thank you very much for your patient listen. That's all about today's session.